Okay, I'm going to do an example of balancing a redox reaction using the half reaction method under basic conditions. What you are given here in worksheet 2, example 3, is aluminum combining with nitrate to create the aluminum oxygen 2 anion and ammonia. So the first few steps are the same as under acidic conditions. You split it into the half reactions, aluminum and nitrogen-based reactions, like so. Make sure you keep those charges. One of the most common mistakes in these questions is forgetting to write a charge, and then when you reach the balancing charge step, it just doesn't work out and you get frustrated. Second step, make sure the aluminum and nitrogen or the non-oxygen hydrogen elements are balanced. They are. And then balance oxygen by adding water. This is the same as acidic conditions. You have 2 waters on the reactant side and 3 on the products for your second half reaction. Now comes balancing hydrogen. So you're going to start by doing it the same way as you do in acidic conditions. Here from the water you have 4 hydrogens, so you need 4 of these hydrogen cations, and here you have 9 being produced, so you need 9 H plus on the reactant side of the second half reaction. But under basic conditions, hydrogen will be immediately neutralized by hydroxide. You know that when a solution is basic, there is a greater concentration of hydroxide ions than hydronium. So by producing hydrogen or adding an acid, you're going to neutralize the equation. A neutralization reaction would be the combination of your acid and your base to create water, and that's exactly what happens. You're going to add that hydroxide for every hydrogen that you added to your equation, but you're going to do it both to the reactants and product side to maintain a balanced half reaction. So here, 4 hydroxides will react with those 4 hydrogens, but putting them on each side of the reaction, you keep this half reaction elementally balanced. Charges aren't balanced yet. These will create 4 water. And then you could simplify this half reaction even further, saying, well, since there's 4 water being produced and 2 being used up, it's just a net of 2 being produced. Do the same thing for the second half reaction. 9 hydroxides are being combined with the 9 hydrogen, and you put them on both sides. This is 9 water, which will then simplify to just 6 water as a reactant because you had 3 as a product from balancing oxygens in that earlier step. I'm going to rewrite this out so that we have a neater half reaction to balance the charge. So now we've accounted for the basic conditions and all our elements are balanced. We need to look at the actual redox reaction that's happening and balance our charge. So you have a -4 on the reactants of your first half reaction and -1 here. So we're going to add 3 electrons to the product side to make sure each side has a -4 charge. You have -9 because of hydroxide in your second half reaction and -1 on the reactant side. So we're going to add 8 here to ensure that both sides have a -9 charge. The redox reaction has to have the same amount of electrons being gained and lost. So we're going to have this times 8 and times 3 so that the oxidation and reduction half reactions are balanced. You multiply every coefficient by 8, so that will be 32, 8, 8, 16, and multiply all of them, and this will be 24, and then you multiply all of them here by 3. So you have 18, 3, 3, and 27. The last step is add up all of the species in both half reactions together, canceling out any common compounds that appear on both the products and reactants side. So let's look at the reactants first. You have 32 hydroxide as a reactant and 27 as a product. This means that you have a total of 5 hydroxides as a reactant. You have 8 aluminum and 3 nitrate. And then you have 18 waters as a reactant and 18 products as a product in your first half reaction. So these will go away and this will become just 2 water. And then your only products that are left are your aluminum oxygen anion and ammonia. And that is your balanced half reaction. You could not use the oxidation number method because in the original equation you didn't know the source of the hydrogen. Because it was in basic solution, you knew that it was aqueous and that the hydroxide and water would be that source of hydrogen. And by doing the half reaction method, you can get your final balanced chemical equation.